The AI industry has spent years promising a future where artificial intelligence becomes our most powerful tool, a tireless assistant, a brilliant researcher, a coding partner capable of helping humanity solve problems faster than ever before. But what happens when that tool starts improving itself? What happens when the world's most advanced AI systems no longer wait for human instructions, and instead begin writing their own code, optimizing their own capabilities, and accelerating their own evolution? And perhaps the most unsettling question of all, what happens when the companies building these systems start warning governments that the technology they're creating may soon become impossible to fully control? Have we already crossed the point where artificial intelligence is no longer just a tool, but a participant? Because that is exactly where the conversation has arrived. Behind the headlines about chatbots and AI assistants, a much bigger story is unfolding. A story involving billion-dollar AI companies, the United States government, national security concerns, autonomous software agents, military implications, and a future that even the engineers building these systems admit they cannot fully predict. At the center of that story is one company, Anthropic. And according to some of its latest warnings and research, the race towards superhuman artificial intelligence may be moving faster than almost anyone expected. This is the story of Claude AI, the rise of autonomous code generation, growing concerns inside the AI industry, and why some experts believe the next few years could redefine the relationship between humans and machines forever. For decades, computers were fundamentally simple tools. No matter how powerful they became, they always required explicit instructions. A calculator could perform millions of operations per second, but only if someone entered the numbers. A spreadsheet could analyze enormous data sets, but only if someone designed the formulas. Even sophisticated software followed the same basic rule. Humans gave commands. Computers executed them. That relationship remained largely unchanged for generations. Then artificial intelligence arrived. At first, AI seemed like just another software upgrade. It could answer questions, generate images, write emails, summarize documents, translate languages. Useful capabilities, certainly, but nothing that fundamentally challenged the traditional relationship between humans and machines. The human remained in control. The AI simply responded. But beneath the surface, something much bigger was happening. Researchers weren't just teaching machines to follow instructions. They were teaching machines how to reason, how to plan, how to solve problems, how to make decisions, and perhaps most importantly, how to generate new information. The implications of that shift are enormous, because once a machine can generate solutions rather than simply execute commands, the nature of software itself begins to change. Instead of programming every step manually, humans can simply describe the goal. The AI figures out the path. That may sound like a small distinction. In reality, it's one of the biggest technological transformations in modern history. And nowhere is that transformation more visible than software development. Software powers nearly everything in modern society: banks, hospitals, governments, transportation systems, communication networks, military infrastructure, energy grids, the internet itself. Every application, website, platform, and digital service relies on code. For decades, writing that code required highly trained engineers. Developers spent years learning programming languages, frameworks, architectures, and debugging techniques. Creating software was difficult, time-consuming, expensive. Then AI entered the picture, and suddenly machines could write code. At first, the results were modest. Simple scripts, basic functions, small productivity boosts. Many engineers viewed the technology as helpful but limited, a useful assistant, not a replacement. But every new generation of AI models became more capable. What once required a team of developers could increasingly be handled by a single engineer working alongside an AI system. Tasks that previously consumed hours could be completed in minutes. Entire workflows began changing. The acceleration was astonishing. Then something happened that demonstrated just how rapidly this revolution was unfolding. The world's largest software development platform began experiencing strain from AI-generated activity. GitHub, the platform used by millions of developers around the world, witnessed an explosion in AI-assisted coding. For years, software growth was primarily driven by humans. Developers wrote code. Developers submitted changes. Developers created projects. Now AI systems were generating code at unprecedented scale. The numbers began climbing rapidly. Every month brought more AI-generated contributions, more AI-assisted commits, more machine-produced software. The pace became so intense that many industry observers started asking a fundamental question. If AI can generate software faster than humans, what happens when AI becomes responsible for creating a significant percentage of all code on Earth? That question becomes even more important when we examine what is happening inside the companies building these systems. Anthropic is one of the most influential AI organizations in the world. Founded by former researchers from OpenAI, the company was created with a strong emphasis on AI safety. From the beginning, Anthropic positioned itself differently. The company's mission wasn't simply building powerful AI. It was building powerful AI responsibly. That distinction matters. Because while many technology companies focus primarily on capability, Anthropic has repeatedly emphasized risk. Its researchers frequently discuss the potential dangers associated with increasingly advanced AI systems. And some of their warnings have attracted significant attention in both government and industry circles. One area of concern involves the possibility that highly capable AI systems could be misused. Imagine a future where AI systems become powerful enough to assist in designing sophisticated cyber attacks, or identifying vulnerabilities in critical infrastructure, or helping create advanced autonomous weapons. Those possibilities are no longer confined to science fiction. They are active subjects of discussion among researchers, policymakers, and national security officials. As AI capabilities continue improving, governments around the world face a difficult challenge. How do you encourage innovation while preventing catastrophic misuse? Too much regulation could slow progress. Too little regulation could create entirely new risks. Finding the balance may be one of the defining policy challenges of the next decade. And that challenge becomes even more complicated when AI begins acting less like software and more like an autonomous worker. One of the most significant developments in recent years has been the emergence of AI agents. Traditional software waits for instructions. Agents can pursue goals. They can navigate interfaces, use tools, gather information, complete multi-step tasks, and increasingly they can operate with limited supervision. Think of the difference between a calculator and a personal assistant. A calculator performs a specific operation. A personal assistant can coordinate multiple activities to achieve an objective. Modern AI systems are gradually moving toward that second category, and companies are racing to make them more capable. OpenAI introduced features that allow AI systems to interact with computers. Anthropic pushed Claude toward increasingly sophisticated reasoning and coding abilities. Other companies joined the competition. The industry entered a new phase, a phase where AI wasn't simply generating text. It was beginning to take action. This shift helps explain why AI products have captured so much attention. Users are no longer interacting with static software. They're interacting with systems that appear increasingly capable of independent problem solving. For many people, the experience feels almost magical. Describe a task, receive a solution, ask for software, get functioning code, request analysis, receive detailed insights. The barrier between idea and execution is shrinking. But every breakthrough raises new questions, especially when those breakthroughs involve code. Because code is unique. Unlike text, code can change the world directly. Software controls machines. Software manages infrastructure. Software processes financial transactions. Software operates communication systems. Software influences national security. If AI becomes exceptionally good at writing software, the consequences extend far beyond productivity. And according to reports emerging from Anthropic and other leading labs, that future may be arriving sooner than expected. Inside Anthropic, engineers have increasingly described AI systems becoming deeply integrated into software development workflows. Some reports suggest that AI now contributes substantial portions of code within certain environments. Developers review. Developers supervise. But the volume of AI-generated work continues increasing. This represents a profound shift. Historically, developers created software and computers executed it. Now developers increasingly guide AI systems that create software on their behalf. The human role is evolving, from builder to supervisor, from creator to coordinator. And while that change boosts productivity, it also introduces uncertainty. What happens when engineers rely heavily on systems they don't fully understand? Modern AI models are extraordinarily complex. Even the researchers who build them often cannot explain every decision they make. The systems work, but their internal reasoning processes remain partially opaque. This phenomenon is often described as the black box problem. Inputs go in, outputs come out. But the precise chain of reasoning inside the model can be difficult to interpret. Now imagine that black box writing software. Imagine it generating thousands of lines of code, millions of lines, entire systems, at incredible speed. The productivity gains could be revolutionary, but so could the risks. A hidden flaw, a misunderstood behavior, an unexpected vulnerability. At sufficient scale, small mistakes can produce enormous consequences. That concern helps explain why AI safety has become such a major topic. And nowhere is that concern more visible than discussions about autonomous improvement. For years, one concept has fascinated AI researchers: recursive self-improvement. The idea sounds deceptively simple. An AI system improves itself. Then the improved version improves itself again, and again, and again. Each generation becomes more capable than the last. the process accelerates. Theoretically, this could create an intelligence explosion, a scenario where progress moves so rapidly that humans struggle to keep pace. For decades, this concept existed primarily in academic discussions and speculative debates. Many researchers viewed it as distant, interesting but not imminent. Today, the conversation feels different, because AI systems are already helping create software. And software improvements can lead to more capable systems. The feedback loop has begun, not necessarily in its most dramatic form, but in recognizable ways. AI helps engineers build better AI. Better AI helps engineers work faster. Faster development produces more powerful models. More powerful models generate better software. The cycle continues. This doesn't mean superintelligence is arriving tomorrow, but it does mean the mechanisms that could enable rapid acceleration are becoming increasingly visible. Anthropic has explored multiple future scenarios involving advanced AI. Some are relatively optimistic. Others are considerably more concerning. In one scenario, AI dramatically boosts productivity while remaining under meaningful human oversight. Governments adapt. Industries transform. Economic growth accelerates. Humanity benefits enormously. In another scenario, competition intensifies. Nations race for AI superiority. Companies prioritize capability over safety. Development accelerates faster than governance. Risks begin accumulating. And then there is the scenario that generates the most attention. A future where AI systems become capable of improving themselves with minimal human involvement. A future where machines contribute directly to the development of their successors. A future where progress becomes increasingly difficult to predict. This possibility sits at the heart of many modern AI debates. Not because experts agree it will happen, but because nobody can confidently prove it won't. And uncertainty becomes dangerous when the stakes are this high. The national security implications alone are staggering. Military organizations around the world are paying close attention to AI advancements. For obvious reasons, superior intelligence has always been a strategic advantage. Throughout history, nations competed for better weapons, better communications, better logistics, better information. Artificial intelligence touches all of those categories simultaneously. An advanced AI system could potentially accelerate research, optimize planning, analyze intelligence, support cyber operations, enhance autonomous systems. The strategic incentives are enormous, which creates another challenge. Even if one organization chooses caution, competitors may not. Every major technological revolution has contained elements of competition. The AI race appears no different. Countries understand what is at stake. Technology companies understand what is at stake. Investors understand what is at stake. The result is intense pressure to move quickly, sometimes faster than society can comfortably absorb. Meanwhile, the capabilities continue improving. Only a few years ago, AI systems struggled with relatively basic tasks. Today, they can write software, generate research summaries, analyze documents, create content, and assist with complex reasoning. The trajectory is unmistakable. Each generation becomes more capable, more useful, more integrated into daily life, and perhaps more difficult to ignore. This creates a paradox. The same technology that promises extraordinary benefits also creates extraordinary uncertainty. AI could help cure diseases, accelerate scientific discovery, improve education, enhance productivity, expand access to knowledge, transform countless industries. Yet the same technology could also create new vulnerabilities, new concentrations of power, new economic disruptions, new security challenges. Both realities can exist simultaneously. And understanding that tension is essential, because discussions about AI are often dominated by extremes. Some people predict utopia, others predict catastrophe. Reality is likely to be more complicated. Technological revolutions rarely unfold exactly as expected. The internet transformed society, but not in the ways many early predictions imagined. Social media connected billions of people, but also created unexpected consequences. Smartphones revolutionized communication while introducing entirely new concerns. AI will likely follow a similar pattern. Transformative, powerful, beneficial, complicated, and full of surprises. Perhaps the most important question is not whether AI will continue advancing. It almost certainly will. The more important question is whether human institutions can adapt quickly enough. Can governments create effective oversight without crippling innovation? Can companies prioritize safety while remaining competitive? Can societies prepare workers for dramatic changes in employment? Can researchers maintain control as systems become increasingly capable? Those questions remain unanswered. And that uncertainty explains why warnings from organizations like Anthropic attract so much attention. These are not outsiders speculating from a distance. These are people building the technology, people with front row seats to its rapid evolution. When they discuss risks, policymakers listen. When they discuss opportunities, investors listen. When they discuss future scenarios, the entire industry pays attention. Because the future of AI is no longer a theoretical discussion. It is unfolding in real time. Every month brings new capabilities, new products, new breakthroughs, new concerns. The pace itself has become part of the story, and that pace may be the most important detail of all. Human civilization typically adapts gradually. Technology improves. Institutions respond. Society adjusts. The AI era appears different. Advances are arriving at extraordinary speed. Faster models, better reasoning, more autonomy, greater capability. The interval between breakthroughs continues shrinking, which means decisions made today may shape outcomes for decades. That is why the conversation surrounding Claude, Anthropic, autonomous code generation, and AI safety matters so much. This is not merely a story about software. It is a story about power, about control, about responsibility, about the future relationship between human intelligence and machine intelligence. And perhaps most importantly, it is a story about choices. The choices made by engineers, the choices made by executives, the choices made by governments, the choices made by society itself. Because technology does not determine the future on its own. People do. The tools we build reflect the priorities we choose. If AI becomes one of the most powerful technologies in human history, then the decisions surrounding its development may become some of the most important decisions humanity has ever faced. Will AI remain a tool that amplifies human potential? Will it become an autonomous partner in solving civilization's greatest challenges? Or will the race for capability outpace our ability to manage the consequences? Nobody knows for certain. Not Anthropic, not OpenAI, not governments, not researchers. And that uncertainty is exactly why the debate is becoming so urgent. The rise of Claude AI, the acceleration of autonomous coding, and the warnings emerging from the world's leading AI laboratories are not isolated events. They are signals. Signals that a new technological era is taking shape. An era where machines increasingly contribute to the creation of other machines. An era where software writes software. An era where intelligence itself becomes a scalable resource. Whether that future becomes humanity's greatest achievement or its greatest challenge remains an open question. But one thing is clear. The age of passive computers is ending. The age of autonomous intelligence is beginning. And the decisions made over the next few years may determine what happens next. As always, the goal isn't to fear the future. It's to understand it. Because the most important developments in artificial intelligence are rarely the ones making headlines. They're happening quietly inside research labs, data centers, government briefings, and engineering teams working behind closed doors. And right now, those developments are accelerating faster than ever. The rise of Claude AI, the push toward autonomous code generation, and the growing discussion around recursive self-improvement all point toward the same reality. AI is no longer just a tool that follows instructions. It's becoming a system that can increasingly participate in the creation of new technology itself. Whether that leads to unprecedented prosperity, unprecedented disruption, or something in between will depend on the choices humanity makes today. The question is no longer whether artificial intelligence will change the world. The question is how much change society can handle, and who will ultimately remain in control as these systems become more powerful. And that may be the most important technology story of our lifetime. If you enjoyed this deep dive, make sure to subscribe to the AI Ledger for more investigations into artificial intelligence, emerging technologies, tech policy, and the future that's being built right now. And let me know your thoughts in the comments. Do you believe AI will remain a powerful tool under human control? Or do you think we're witnessing the early stages of something far bigger than most people realize? Thanks for watching. And remember, the future isn't arriving one decade at a time anymore. It's arriving one breakthrough at a time. We'll see you in the next one.